Hello, this is Mr. Zanetto. Just going to go over 13b, which is working with proofs that involve corresponding parts of congruent triangles are congruent. And remember, for us to have corresponding parts of congruent triangles are congruent, we're going to have congruent triangles. So we also need to remember from 13a the side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. Those are the 5 ways to prove triangles are congruent. And then once we have congruent triangles, we can use this to allow us to expand that information to any other parts of the triangle that we don't know are congruent. In fact, they have to be, since the triangles are congruent. So here we go. We're going to go ahead and normally they give us this information. We write it down here. The first step in this particular proof, I would make sure that AD is congruent to CB is marked in my triangle, and that AD is parallel to BC is marked in my triangle. And once you have that, that's the given information, and I like to go ahead and wait until I make sure that's all there. Now I have that in my given information. Once I have that given information marked, now I need to come up with a way. I'm looking to prove, in this case, I'm not going to use CPCTC because all I'm doing is proving the triangle is congruent. So from here, I go ahead and say, what else do I have? Do I have vertical angles? No. Do I have a shared side? Hey, I do have a shared side. And that's probably one of the first things I would put down is DB is congruent to DB by reflexive property. Remember, it's a shared side, but we use the reflexive property of congruency because that's the mathematical way of saying, yes, this side is congruent to itself. So now we have 2 sides. 2 pairs of sides that are congruent. And a lot of times I'll insist on students marking that this is a side, and this is a side, this is a side. This side's congruent to this side, this side's congruent to this side. Now, we need to come up with something else. There's a couple options here. As I say that, I realize really there's only one option. What we're going to have here is AD is parallel to BC. Remember, I'm trying to prove this triangle is congruent. This triangle is congruent to this triangle. And for that, I need an angle now, or a side. And I realize I can't find a side that I could prove to be congruent. So from there, I'm going to go ahead and create this transversal. The reason why I create this transversal is it will help me prove that this angle is in fact congruent to this angle by alternate interior angles. Since I have parallel lines, alternate interior angles prove that the 2 angles are congruent. Therefore, angle ADB is congruent to CBD. And that's by alternate interior angle theorem. Once I have that, I can add an angle, and in fact that's the included angle, which now gives me SAS, showing that triangle ABD is congruent to triangle CDB. Now that is a straight out of the book type of proof that we might find in the beginning of this topic. Now from there, I look at these two proofs. These 2 proofs are decidedly different. Why are they different? Because these are proving segments or angles being congruent to each other. Therefore, I'm going to use CPCTC as I listed as one of the things I could do. So here, B. Again, I want to make sure that these are all marked. And in fact, none of these are marked. So AB is going to be parallel to BC, AB parallel to DC. That's given. And it's also given that EB is congruent to EC. That's the given information. Once I have my given information listed, now I can start looking for other things. In this case, we have lots of ways to prove angles congruent. I always think shared side and vertical angle theorem is probably the first thing I'm going to mess with. And here I do have vertical angle theorem giving me that AEB is congruent, AEB is congruent to DEC. So now I have a side. Anything else, I would be in trouble because I need three things always to prove triangles congruent. I'm going to need the triangles to be congruent to prove that AE is congruent to ED because it's nothing real obvious there. From there, I'm going to go ahead and again consider my parallel lines. And I need a transversal. And that transversal could be either of two. It could be BC or AD. And which one I pick will determine which proof or what way to prove the triangle is congruent. I'm going to go ahead and do AD. If AD is parallel, that allows me to say that this angle is congruent to this angle. Angle A is congruent to angle D. Angle A is congruent to angle D, and that is by alternate interior angle theorem. And once I have alternate interior angle theorem and I have that angle congruent to this angle, I have angle, this is angle. I have angle, angle, side, angle, angle, side. Notice the side is not included between the two angles. That's why I'm going to use the theorem that has the side not in between the two angles. And that's going to give me triangle AEB congruent to triangle DEC. Let's make sure those correspond. EC is corresponding to EB. Those are congruent, as well as the angles, and then the angle E's are matched up. Yep. So everything's matched up. I like the way it's paired up. Now, I can further say that EA is congruent to ED by corresponding parts of congruent triangles are congruent. And we're good to go. So that's that proof. Got the triangles congruent, then we use CPCTC to get that other side congruent. The next one, we're going to go ahead here, the given information, make sure it's all marked. Given AC, DB, AC, DB, AB, DC, and then I also have a shared side, so I'm going to go ahead and get that information in. BC is congruent to BEC by reflexive property of congruency. That's the mathematical way to say that it was a shared side. Then from there, now I have pair of sides congruent, another pair of sides congruent, and a last pair of sides congruent. So I end up with side, side, side. So side, side, side will give me triangle ABC congruent ABC to DCB. Notice I go down that one. I'm very confident these are matching up. One tick, two ticks. And 1 tick, 3 tick, 1 tick, 3 tick. It works. Once I have that, now I can say that the angles, corresponding angles, ABC is going to correspond to angle DCB by corresponding parts of congruent triangles are congruent. And these are the two that dealt with corresponding parts are congruent to, corresponding parts of congruent triangles are congruent. Thank you and have a good day.